This time, an introduction to projectile motion. Let's learn physics. From the instant the ball is released to the instant it touches the ground, it is a projectile. Its path looks like this. If there is negligible air friction, the only force applied to an object in flight is its weight. The direction of that weight is straight down. It is the net force, and by Newton's second law, the acceleration caused by that weight, the net force, is also down. Therefore, during projectile motion, there is no acceleration in the horizontal direction, and the velocity in the horizontal direction is constant. And of course, the vertical velocity will change, and that acceleration, that rate of change, is about 10 meters per second every second down. Since the horizontal and vertical components of velocity act very differently, and they don't affect each other, we therefore say that the horizontal and vertical are independent, and we use that as the center of our problem-solving technique. You can see here in this quick sketch that the Vx stays the same and that the Vy is constantly changing. Keying in on the idea that the horizontal and vertical are independent, here's how we're going to solve our problems. First, sketch the situation. Then, because of the independence, separate those x and y's into two separate columns and use those same kinematics equations we've been using for quite a while. X and y are independent, two separate columns. In the horizontal, there is zero acceleration. In the vertical, the acceleration is 10 meters per second every second. The acceleration of gravity down. The one thing that can be transferred back and forth from one column to the other is time. But before you do anything else, sketch first. Put all the values on that sketch. The horizontal velocity and the vertical initial velocity are different. Keep them separate and in separate columns. In the horizontal column on the left-hand side, remember that the acceleration is zero. Record the horizontal velocity that is constant, the horizontal displacement, and use the only equation available to you because there is no acceleration. The constant velocity in the x direction is displacement over time. Same thing in the y column. For the vertical, the acceleration, however, is 10 meters per second every second down. I'll use a negative because I'll use up as positive. Record the values that you have and then use whatever equation is needed to find what you're looking for. So quick summary. For projectile motion problems, always sketch first. Make it a good sketch. Make sure you understand what is going on so that you can then fill in the two completely separate columns for the horizontal and the vertical using the appropriate values. Remembering that time is the only value that can apply to both columns. And if you find it on one side, you can transfer it to the other. The key being that the horizontal and vertical are independent of each other.